Well, hey there, everybody. Today we're working on, we'll call it part 2.5 of setting up a neon processing plant. Part 1 was the build of the bench. Part 2 was the wiring and electrical. You can see links for those two in the description below if you haven't checked those out yet. And part 2.5 here, I had some finishing touches I wanted to do before I started on part 3, which would be the vacuum system. I had a couple corrections I wanted to make from the last video. I had a couple errors regarding the bombarder under here. This solo bombarder, I had mistakenly told you guys it was around 200 pounds. It turns out it is about 275. It is very heavy. I was also incorrect about the age of the unit. I guessed, well, the model number is 5533. I thought it may have been from 1933 because sometimes transformers are dated with the model number, but turns out this is probably from the late 40s or 50s, so it's still very old, but a couple corrections on that one. And the other thing I want to talk about are these pass-through insulators I got up here for the Jacob's ladder. I discovered what these actually are. Some of you may know, and I'll give you a hint here. Well, we got one side is glazed and the other is not. It's a bit of a hint, but I want to take you on a little field trip and we're going to find them. So here we go.
Good day, mates. Today on Transformer Hunter, we're deep in the suburban jungles of North America, approaching the habitat of the elusive Transformicus erectus, commonly known as the pole pig. Now, we're approaching quietly as to not startle them, and if we're lucky, we might just catch a glimpse of... Oh, crikey, there's one now. Oh, look at that. She's a beaut. Oh, you're alright, mate, you're alright, we're not going to hurt you. Oh, we just want to get a look at you. Now, this specimen is a prime example of a transformer of the step-down variety. You can see a large primary insulator sticking out the top there. And if you look closely, there are 3 secondary insulators sticking out the side. And those secondary insulators are what we're using for the Jacob's ladder on the Bombarding table. Alright, let's get back to work.
So, mystery solved on where those came from. So now we'll get to the parts, finishing this, the tasks I wanted to do on this table. And first one is involving safety. I wanted to get a high voltage sign mounted visibly on this table for in case I have visitors at the shop or something, and then I wanted to show them how to process. Of course, they wouldn't be anywhere near the table, but a good idea to have some visual reminders for myself, if anything. So I'll put you down here and get that mounted. All right, there we go. And next thing I want to do is address the raw cut edge on the bench top here. Well, this is particle board, and kind of can chip and snag, especially if I'm leaning up against it to work on things. So I wanted to finish off the edge. I got some of this bumper kind of strip and run that around. I got a router to cut the slot for the strip and a slot cutting bit. So we'll run that around the edge, make a slot, and friction fit this into the edge of the tabletop. All right, so we're all set up. Haven't ever really done anything like this before, so I'm going to start at the back in case I mess up and it won't be so glaringly obvious. All right, well, It's got a slot in it. All right, so we'll put the strip in. I'll tap it in with a rubber mallet and use a razor blade to notch the corners. Turns out these corners do a radius pretty well, so just cut a notch out and then continue tapping it in. Not bad at all. All right, turned out pretty well, actually. There's the end on this side. Like I said, these corners did better than I thought they would. And yeah, looks pretty nice. Better than that raw edge that we had earlier. Cool. As I suspected, I messed up the back edge a little bit, adjusting the height or the depth so I could cut it directly in the middle, so that it wouldn't be standing proud above the top of the table. So I might have to wrap it with some electrical tape, kind of fudge it on a little barb so it'll actually friction fit in the slot. But the rest of it turned out really well. And turns out even if you mess up little spots in between, the rest of it will hold it in there. So very good. All right, on the back here, that electrical tape idea worked out pretty well. Gave enough thickness to fit in the larger slot that I accidentally cut. And I stuck a little screw in the end right there just to hold it in. A little bit of insurance, but shh, don't tell anybody. That'll be our little secret. All right, on to the next task. All right, and to measure the output of the Bombarder, the high voltage output, I got this milliammeter. This is 0 to 500. I think my bombarding transformer goes up to 635, but I'm really probably gonna process one tube at a time, and doubt I'll be using more than 500 much. So, but yeah, it looks like it's an old stock. Pretty nice looking milliammeter. Nice readable display, but it does not have any sort of box, so I'm going to make one. This is a 6x6x4 PVC junction box. This one happens to be a Scepter JB 6x6x4. So yeah, we're gonna measure out the mounting holes in the main body there, and drill them out of this lid and mount that thing in the lid. All right, so I did some measuring and some sketching on the lid here of the dimensions for the milliammeter, and I got the middle of the circular part marked out for my hole saw, my very resonant hole saw, which happens to be 3 inches, also 76 millimeters, just marked right on there, so I don't even have to figure out later for our metric friends. But I thought I'd show you my pencil. Yeah. Pretty groovy. Anyway, I'm to the point where I'm going to cut a hole for that cylindrical part in the lid, so we'll take a look. All right, here we go. Moment of truth. Hope I measured correctly. I got a little bit of wiggle room on either side of the cylindrical body, so I think that should be all right. Oh man, that smells lovely. Burning PVC. Check it out. Ooh, fun. Psychedelic, man. All right, got the holes for the mounting studs marked, and let's drill them out here. You get the idea. Oh, there you go. On the back, we got these little ridges that we gotta take down so the washers will fit. Like that. All right, then we got it properly secured to the lid. And that's what it'll look like when we got it. Hook up the GTO output from the Bombarder, and we should be good to go. Self-powered, well, it's powered by the electricity running through it, so. All right, and so for the attachment of the milliamp gauge, I decided to make another one of these brackets. This came off of my Bombarding temperature gauge. It's just aluminum. This happens to be 1 inch. I think it's an 1/8 inch thick. And I had some scrap pieces of 3/4 inch aluminum lying around, so I thought I'd try to make one out of that. I'll just bend it to see if we can match something that will fit on there, and call it good. All right, and I got it clamped in these vice grip jaws here. Let's see if we can just bend it to a right angle. Be nice if I had a vise, right? That would make too much sense. Is that a 90? Maybe a little too sharp. All right, well, we'll do the other side. I decided to tap on it with a hammer, and that sharpened the angle up a lot better like that. So we'll do that some more. All right, now we'll try the other side. We're going for something about this size. Yeah. Not bad. Just got to trim it down a little bit and drill some holes. We'll do it again for that. Get it put together. All right, there it is. That's what I wanted the brackets to look like. That way, I can adjust it and tighten it down. All right, so I got the Bombarding milliammeter attached to the table. It will be wired in series with the Bombarder leads, so we'll have to get drill a couple holes to get the wires into there. I have what are called cable glands. Cable gland, and they are used for waterproofing and strain relief. Not well, hopefully won't be much water around this table, so we'll be just using them for strain relief. They are 5 parts, 3 plastic and 2 rubber gaskets. One seals on the cable and the other seals on the housing inside to keep the water out. These are, I got a variety pack. These are metric, and they're PG stands for, it's a German word, Panzergewinde. My friends from Deutschland will have to let me know if I'm pronouncing that correctly, but it's a German screw thread standard. So these just happen to be 18 inches wide, and I have a 19-inch hole saw, so that will be just fine. And then we'll run the GTO through there. GTO stands for gas, tube, and oil, and it is high voltage wiring. Gas tube as in neon, and oil as in oil burning ignition wire. So this is a GTO 15, which is rated for 15 kilovolts. And normal GTO is about 6 millimeters, a little over 6 millimeters wide. But I wanted something a little beefier if I could find it. And silicone, because silicone is much more flexible. And this Transco GTO 14 gauge GTO 15 is 9.4 millimeters in diameter. It has a lot of insulation comparatively. So yeah, I figured the more insulation on the Bombarder leads, the better. Keep the current where I want it. So we're going to drill some holes in the junction box here, install some cable glands, and then run the GTO into the meter. I'll spare you the drilling, but I'll bring it back here in a little bit. So to attach the GTO to the meter, I'm going to use these little ring terminals. They're crimp-ons, but I really don't want them popping off, so I'm going to solder them as well. So I got the stripped end of my GTO here. Get a little flux on it, and slide this ring connector on. You guys can see it. All right. So crimp it. And clamp it. Clamp. All right. Soldering iron here. Turn the tip a little bit. Right. No one said I was a professional. Clean a bit of the flux off with some rubbing alcohol. Excess flux. And there we go. It's well secured. Now I got the cable gland on there already. Clever. So we'll just feed it through the hole in the box and attach it to the meter. Got to do the other end of the output as well, so get that one done. All right, we'll see if you can see this while I'm doing it. So loosen this cable gland so I get some slack. There's one. Good. The other. This will have to be rotated this way. Anyway, I'll get a ratchet and tighten these down, but snug, and this one's gonna be, I don't even know if you can see this. Here we go, like this. All right, and then we put it back in, screw it down, and that, my friends, should be it. Almost forgot to zero out the mechanical zero screw. Yeah. And now we have the bombarding temperature gauge attached to the bench, again at about eye level, or close to eye level to avoid parallax. This does not require any external power. It is a thermocouple temperature gauge, and you can see the thermocouple there is a bead, two dissimilar metals in the wire there, and the temperature differential of the the DC current generated by the temperature differential of the two dissimilar metals will power this gauge, and it will move the meter. So I've got that hooked up, and last thing I wanted to do was the light bulbs. I have a couple different kinds here. The smaller ones, these S11s, these are incandescent, they are 11 watts. And then I got the larger A19 size in 8 watt LED bulbs because they draw less power. However, they are 60 watt equivalents. I don't know if they're going to be too bright when all three of these are lit right in my face as I'm standing here pumping. So we're gonna try them both and see which one. Obviously they need to be visible, you know, to kind of be alert you of the activation levels of the bombarder, but we'll try them both out and see which one we like better. All right, now I have the S11 bulbs installed. Hopefully the camera sensor will pick up the differences in lumen output, but give it a shot here. So we got main power on. Secondary safety switch on. Bombarder. And the final verdict is S14s. I decided those A19 bulbs were just a little too bright and in your face. They were actually kind of distracting, a little just kind of blinding. So I want to be able to concentrate on doing things correctly in the proper order and not making mistakes due to unnecessary distractions. So we're going with the S14s. Since they're incandescent, they don't last as long, but they're like, I don't know, 2,500 hours, which will be along a lot of bombardings. Keep the LED ones around just in case I need a replacement in a pinch. But for now, we're gonna go with that. All right, and that's about it for the finishing touches I wanted to do on the bench. before the vacuum setup. So stay tuned for part 3. We got the vacuum motor waiting patiently over here, vacuum pump, and we got the manifold as well that will have to be assembled. So thanks for watching. Stay tuned, hit subscribe for more neon related videos, and we'll see you next time.